Alrighty, ladies and gents, this video is all about the different rules for logs, which we can use to help us condense and expand logarithmic expressions. Explain more of that in just a second. Alright, let's go over some rules for logs. First of all, let's talk about the product rule for logs. So logs are cool in the sense of, if I have the log base b of x times y, so one thing times another, I can actually break that up into two separate logs, and those two separate logs are log base b of x plus log base b of y. So when I'm multiplying two things in my argument of my log, I can break it up as the sum. I can add those two logs. The quotient rule for logs says, what if we were dividing our arguments? So what if it's log base b of x divided by y? What does that equal? Well, we can once again separate that into two separate logs. And the key here for all these rules is that the logs have to have the same base, right? And so it's going to be log base b of x minus log base b of y. So the difference here is that we went from plus to minus. Easy way to remember that is, multiplication, repeated addition. Division is repeated subtraction. And in a second, when we get to some homework questions, some examples, we're going to be going both directions. They're going to give you a log that's already been condensed, and they're going to ask you to expand it out into multiple logs. And they're also going to ask you to go in the reverse. They're going to give you multiple logs and ask you to condense them, into a single log. All right, before we do that, a couple more rules here. The power rule for logs says, hey, if I have log base b of some x raised to the p power. So here it's assumed that, your base x is not the same as your base b, or even if it is the case, you can still do this. But what you can do is you can take the power, the exponent, on your argument, and you can bring that out front and multiply it by the log base b of x. So that's what the power rule says. And then lastly, I just wanted to throw it in here, some inverse rules. We've already talked about one of them in a previous video. But if you recall, the log base b of b to the x, that equals x. Why is that? Because, well, first of all, when the bases are the same of your exponential and your log, the answer is just the exponent. In this case, it's just your x. And then a new rule here is b, when we have a base b raised, so this is the base of the exponential, when our b is raised to a power log base b of x. So once again, the base of the exponential is the same as the base of the log. Because they're inverses, the answer is going to be just the argument, just x. Okay? All right, so we're going to use all these rules throughout the various examples. All right, here we go. For example, suppose we had the natural log of x squared divided by z cubed times y. Let's say we had that, and let's say the question asked us to expand the logs. So they want us to expand that single log into separate logs with no exponents. Okay, and I'll explain what that means in just a second. Okay. So what does this mean? So first of all, if we go back to our power and quotient rules, this is all you need to know, folks. Whenever you're trying to, maybe before we jump to this, let's do this. The rule says this. Suppose I had log base 4, right, of, let's say 4 times some value, let's call it x, 4 times x. What this means is I can break this up into the log base 4 of 4 plus log base 4 of x. Okay? That's what that product rule is telling you. In a similar fashion, the quotient rule is telling you, what if we had log base 7 of, let's say, c over 8? Well, that would be log base 7 of c minus log base 7 of 8. Make sure I put my arguments in parentheses. Okay, put your arguments in parentheses. All right, so the only difference between these two, folks, is that notice how, go back to the quotient rule that we just did. Notice how the 8 was in the denominator, and it ended up with a negative coefficient. Right? But the c, which was in the numerator, ended up with a log that had a positive coefficient. Come back to the first example with the product rule. Notice how the 4 and the x, they're both considered to be in the numerator because they're understood to be over 1. So that's why both of these ended up with positive coefficients. So that's the trick with these, okay? So anytime you have a value in the denominator and you want to expand these logs, that just means it's going to have a negative coefficient because it's in the bottom. So if I were to expand this log, it would be 3 different logs. I have 3 different arguments I can break up my logs about. So this will be the positive natural log of x squared. It's positive because it's in the numerator. Minus the natural log of z to the third. Why is that a negative? Because it's in the denominator. And also I'm going to have another negative for the natural log of y because that's also in the denominator. Okay? The last part of this question says they don't want any exponents on your arguments. So next we're going to apply the power rule. And the power rule says I can take this 2 and I can bring it out front. So this becomes 2 times the natural log of x minus, same thing, take that 3, bring it out front, minus 3 times the natural log of z minus the natural log of y. So there we go, folks. That's how we expand out a log. All right? Okay. We're going to do a few more of these. How about this example? What if we're asked to go the other direction? What if we're asked to condense the following logs? What if it's log base c of 10 plus log base c of 3? Okay. So now we're going the other way. These are already expanded out. We want to bring these together as a single log. So we're doing the product rule here. What this means is that this is going to be a single log of base c. And the log base c of 10 and log base c of 3, they both have positive coefficients. So that means that they're both going to multiply each other up in the numerator. So 10 times 3. Which means this is, if we want to simplify this a little bit, this is log base c of 30. That's what that is. Okay? Here we go. Next example. This is going to be a doozy. Suppose we wanted to expand the following log. Let's say it's log of the square root of x times y squared over z to the 4th. So we wanted to expand that. Alright. So what do we do here? In a previous video, we've talked about this. We said the square root of x is the same thing as x to the 1/2 power. That's because the nth root of x to the m is equal to x to the n over m power. A square root has an understood index of 2. That's why this is 1 over 2 is a power for a square root. So what that means is we need to rewrite our log as this. It's really the log of, let's see here, it's x times y squared over z to the 4th, and because we're taking the square root of that whole thing, we can raise that entire quotient there to the 1/2 power. Alright? And so we want to expand these. But here, the first thing that we have to do is we have to do our power rule. So we're going to take that 1/2 as the power. We're going to bring it out front. So this is 1/2 times the log of x y squared over z to the 4th. Okay? Remember, log is when you don't see the base of the log, it's an understood base of 10, but that doesn't really matter to us. And then what we're going to do is we can now expand this log base 10, this log of x y squared over z to the 4th, similar to what we did in a previous problem. But the key here is that it's going to be that entire thing needs to be multiplied by 1/2. So it becomes this. 1/2 times the quantity, so I'm use brackets here, of log of x, it's in the numerator so it's positive, plus log of y squared, since that's also in the numerator, minus log of z to the 4th. Okay. If the instructions tell you they don't want any exponents for your arguments, things in the parentheses, then we need to do the power rule. Let's do that. Let's keep the 1/2 on the outside. We have log of x plus, we can bring that 2 out front for that middle term there, so 2 log of y minus 4 log of z. And then our last step is to distribute the 1/2 everywhere. So this will be 1/2 log of x plus 1/2 times 2 log of y minus 1/2 times 4 log of z. I distribute the 1/2 to every single term in my brackets there. The next, let's just kind of make this look a little nicer. This will be 1/2 log of x. 1/2 times 2 is just a 1, so it becomes, not equals, but it becomes a plus 1 log of y. And then minus 1/2 times 4. 4 divided by 2 is 2, so that's 2 log of z. All right, folks, that is the fully expanded version of that. All right, let's see, just a couple more. Make sure you guys are rock solid for this homework. What if we had this? What if we had to condense 1/2 log base c of 4 minus log base c of x minus 9 log base c of y. Okay, we're going to do our steps in reverse here. So the first thing I'm going to do is I'm going to go through and I'm going to apply my power rule. So this becomes log base c of 4 to the 1/2 power. Just brought my power, my coefficient back in as a power. Minus log base c of x. We're going to do the same thing. We're going to bring that 9 in. Minus log base c of y to the 9th power. Okay. Next, we're going to combine everything into a single log. So it's going to be a log of base c of. Let's see here. That 4 to the 1/2 is dealing with a positive log, so therefore it has to go up in the numerator. So it's going to be log base c of 4 to the 1/2. We have a negative log base c of x, so that means that my x has to go in the denominator because it has a negative coefficient. And the same thing with that y to the 9th. Because it has a negative coefficient for its log, it's going to go in the denominator. So x times y to the 9th all goes in the denominator. Now, if you want to get super fancy here, remember, what do we say the 1/2 power is? The 1/2 power is the square root. So if we wanted to, we could say, hey, 4 to the 1/2 is the same thing as us taking the square root of 4, which we know is 2. So a fully simplified answer to this, you don't have to do this in homework, would be a log base c of 2 over x, y to the 9th. Okay. All right, hopefully that clears it up a little bit. Let me give you just 2 more quick examples here. So let's apply the inverse properties of logs. So to quickly remind you, instead of scrolling all the way up, remember log base b of b to the x. Remember that's the same thing as x. When the bases are the same, they cancel. And the same thing when we have an exponential. A b raised to the log base b of x, that equals the argument of the log, which is just x. So, if you have a following question, for example, suppose we wanted to figure out, hey, what does the natural log of e to the negative 4x equals. Well, here we have to have a little bit of previous knowledge about logs. And I got you in case you forgot. But remember, the natural log of x is just the same thing as a log. It's a log of base e. Remember, that was one of the special logs we covered in a previous lecture. So natural log of e to the negative 4x is really just another way of saying it's log base e of e to the negative 4x. And we know from our property above, namely this one I'm highlighting now, we know that this equals just our exponent, which is just a negative 4x. Okay, that is a property we're going to exploit a lot in the future videos. Last example for this video is, what if we have 3 raised to the log base 3 of x minus 2? Okay. Same thing. We're exploiting this property. When the base of our exponential is the same as the base of the log, it's going to equal just the argument of the log. So since the base of the exponential is 3, the base of the log is 3, this is going to equal just the thing in parentheses, just the argument, which is x minus 2. Alrighty, folks. Hope that helps you get to the next homework. I'll see you in the next video.